So this problem refers to circle placement in a rectangle. So as you can see in this example, we do have some information regarding the a number of circles. Let's assume that we do have n circles, and what we know about the problem is that the radius of each circle is known. As you can see, we can represent them by Ri, but the question is, how can we place them on a plane surface, on a rectangle shape surface, without overlapping each other, and the surface of that specific rectangle is minimum value. So in order to formulate that, we have to create some constraints and an objective function. The objective function is multiplication of L multiplied by W, which is length and width of that rectangle, and for each pair of circles we do need some constraints. For example, the distance between the center of these two circles should be bigger than Ri plus Rj square in order to avoid overlapping, and also for each x and y, which are representing the center of each circle, we should have the following two constraints. Okay, so these are actually, each constraint is two constraints actually. So Ri is between xi is bigger than Ri and is lower than W minus Ri, and yi is bigger than Ri, less than L minus Ri. Why? Because we don't want the circle to get out of this rectangle. Okay, so in order to show you what's going on, first of all we have to know the input data for this problem. It means that for every I and j, for every I, we have to know the radius of each circle. So in this way we can work on it. Okay, so let me show you the so as you can see here, we do have 6 circles, and for solving the problem we have to find the optimal locations of them. So here you can see the Python code required for solving that problem, and as usual we have to import the required packages, for example Pyomo, Matplotlib, NumPy. We don't need the random package, so I remove that. And also we have to create an abstract model, so we can then easily change the number of circles that if you want. So model I is a set, model.j is another set which is in alias with the previous set. R is a parameter which is defined over set I, and also we do need some constraints, okay, and some decision variables. The decision variables are the centers coordinations x and y, which are bounded with Ri and a big number, because as you saw in the formulation, each x is between, for example, L minus Ri, but we don't know the value of L. So for simplicity, I have chosen a big number here. The same philosophy holds for y and also for W and L. So W and L are positive numbers between 0 and 100, for example. I have initialized all of them. And also for every I not equal to j, we have some constraints. For example, here you can see that x model.xi minus model xj square plus model y.yi minus model.yj square should be bigger than an expression like this, Ri plus Rj square. But you might ask me, why didn't you say I not equal to j and you said I greater than j? This is because if we calculate the distance between two circles, let's say 1 and 2, then we don't need to calculate the distance between 2 and 1. We just need to calculate it once. Then for the rest of them we should skip the constraint, and model.equation1 is following that specific rule. Okay, so rule 2 is telling us x should be less than w minus r. This is another constraint, and the other constraint is for y's. So model.yi is less than equal to model L minus ri. And the objective function is the multiplication of model.w multiplied by model.l. And the objective function should be defined here. Model.obj is equal to objective rule is objective rule here, and the sense is the minimization. The solver chosen for solving this problem should be capable of solving nonlinear programming. Then the instance will be created using the dat file associated with this example, and then we will ask Pyomo to solve it for us. Okay, so let me run each tab one by one. Okay, and this one, number 3, and the final one. Okay, so as you can see here, the optimal locations of each circle is specified and plotted. So let me give you a very quick introduction how I have plotted this graph. So first of all, we have created a fig is equal to plot dot figure fig size. So you specify the size of your figure here, and theta is a linear space between 0 and 2 pi, which is divided into 100 points. And also I have used the scatter command for putting those dots. So for each value of x and y, as we have a for loop here, we put dots here on the surface, and the x center values are also calculated. The center of each plot is here. The scatter is plotting the circle, and the xc and yc, which is representing center values, are created here. And then you can see the graph here. So the solution is graphically shown on these plots. I can also specify the labels for x axis and y axis. Thank you very much.